Alright, so we're on problem 15 of the final exam practice, and in this problem we just want to do some coordinate conversions. So our first coordinate conversion in part A, we're taking the polar coordinates 1 comma pi over 2 and converting this to Cartesian coordinates. So 1 comma pi over 2, let's just draw it. So here's our pole, here's the typical horizontal axis, so the x-axis for our Cartesian coordinates, the y-axis for our Cartesian coordinates, and then we're thinking of the polar axis as being the positive x-axis as usual. So this point 1 comma pi over 2 in polar coordinates, so we're measuring our angle out as pi over 2 radians, so that brings us up to this positive kind of y-axis, and then we're going up a distance of 1. So this is a distance 1 and an angle of pi over 2. So this is in polar coordinates. Okay. We want to convert this to Cartesian coordinates. So if you think about it, our x-coordinate will be 0 since we're on this y-axis, and our y-coordinate should be 1 since we're a distance of 1 away from the origin. But either way, we'll just put in to the formulas. So we have x is equal to our radial coordinate 1 times cosine of the angular coordinate pi over 2. Cosine of pi over 2 is 0, so x equals 0. Y is equal to 1 times sine of the angular component of pi over 2. Sine of pi over 2 is 1, so this gives us 1. Our Cartesian coordinates for the polar point 1 comma pi over 2 is 0 comma 1. Okay, so that's our conversion to Cartesian coordinates. Now let's do it the other way around. Let's go from Cartesian to polar coordinates. So let's say that our Cartesian coordinates are 1 over square root of 2 comma minus 1 over square root of 2. So let's draw where this point would lie. So here's our x and our y axis. So it has positive x-axis, so it's over here either in quadrant 1 or 4, and it has negative y component, so it's going to be in quadrant 4. So this puts us down here in quadrant 4. This is the point 1 comma, or 1 over square root of 2 comma, or yeah, minus 1 over square root of 2. Okay, so 1 over square root of 2 comma 1 over minus 1 over square root of 2. All right, so we know we're down here in quadrant 4. So we know certain things about the angle. If we take a negative angle, it will be acute. If we take a positive angle, it's going to be larger than 3 pi over 2, for example. So either way, we'll know if we're dealing with the correct answer or not. So when we convert from Cartesian to polar, we need to write out our other equations. So we know that r squared is going to be equal to 1 over rad 2 squared plus negative 1 over rad 2 squared. So our x component squared plus our y component squared. This is equal to 1/2. This is equal to 1/2. And so r squared is equal to 1. So we could take r equal to positive or negative 1. It would be our choice, but either way, I'll just go with the positive value of r here. So then to find theta, we can take that to be our theta, or we can take this positive angle to be our theta, or really any coterminal angle to be theta. But either way, so let's take tangent of theta, we know is equal to the y-coordinate divided by the x-coordinate. So here minus 1 over rad 2 divided by 1 over rad 2. And so this, of course, equals negative 1. And so then we know that this angle theta is equal to negative pi over 4. Right, so this angle here is negative pi over 4. Okay, so it has a distance 1 away from the origin with angle negative pi over 4. So we can take this to be our polar coordinates, 1 comma negative pi over 4. All right, so that's the one with the positive radial component. We could have also taken the one with the negative radial component. So just for example, we could have taken our radial component to be negative 1, and that would basically, if we kept the same angle, negative pi over 4, that would put us as this point Well, that's not the proper point, so we would have to add pi or subtract pi from this thing. So I can just say that I add pi to it. It honestly doesn't matter which way you go. So 3 pi over 4 would be the appropriate angle here, adding pi to pi over 4. So either way, you could do with either one of these answers, positive radial component or negative radial component. All right, and that's problem 15.